Hello students, welcome to Sri Jayendra's Rank Zone classes. I'm your friend and mentor with respect to physics for the coming classes. Today we will discuss about the lecture number 6 of units and measurement. So let's begin. If you remember in the previous classes what we have discussed, we already discussed about the errors. We have discussed about the combination of errors, and in the combination of errors we have discussed the errors that has been included in the addition and subtraction. So now let's move to the errors that occurs due to multiplication or division. So let's begin with the errors due to multiplication process basically. Firstly, we are going to discuss about the error due to multiplication. Now let's say we are going to measure a certain quantity which can be determined as a plus minus delta, and we have been measured different quantities that can be given as b plus minus delta b. Now you know that a, this is the true value, and delta, it is an error. B, it's a true value, and delta b, it is an error. So we have discussed in the previous classes that whatever comes after plus or minus, it is an error associated with it, and whatever the comes before plus or minus sign, it is a true value. Yes. So let's say we need to perform z is equals to a into b. That's in multiplication, a multiplied by b. Then its error can be calculated as delta z by z is equals to delta a by a plus delta b by b. While delta z by z, this is called fractional error or relative error. If I have been asked the percentage error associated with the same, what I need to do is I need to just multiply the relative error with 100. So it could be a delta A by A plus delta B by B into 100. So this is what we can say is a percentage error. So let's look how that can be used. Next, error due to division. First, we will understand the error due to division, and then we will switch to the numericals of the same. Again, the same thing, I need to measure an A, and when I measure, I find it as an A plus minus delta. I need to measure B. When I measure it, I find that's an B plus minus delta B. Now tell me what is the error in delta B? Yes, it's incorrect. This is delta B is the error, and B is the true value. Same way, if I have been asked what is the error associated with it, delta A is the error associated with it, and while A is the true value that I know. Now, if I need to perform Z is equals to A by B, if I need to perform Z is equals to A by B, then maximum possible or maximum permissible relative error, which can be calculated as delta Z by Z, that should be is equals to delta A by A plus delta B by B, while delta Z by Z is called as the relative error that we already know. This is what we know as a relative error. If I have been asked the maximum percentage error, I need to just multiply this by 100. So it is a relative error multiplied by 100, which give me a delta A by A into 100 plus delta B by B into 100. Did you understand this? Any doubts? No? So let's look at the numericals of the same. Let's say I need to find out delta F by F. This is force. I have been given that I have measured the mass. It is 100 plus or minus 1 kg. I have been given an acceleration. It would be a, let's say, 50 plus minus 1 meter per second square. And I need to find out the relative error in the calculation of the force. This is the force. So what I know is, I know the relation F is equals to mass times of acceleration. So I can write like this, delta F by F. That should be is equals to delta M by M plus delta A by A. Now what is delta M? It is an error associated with mass. What is error? It's in 1 in this case, divide by M is the true value of a mass. What is it? It's in 100. So this is 1 by 100 plus delta I, error associated with an acceleration. It is a 1 divided by true value of an acceleration. It's in 50. So while I solve this, I can write like this 1 by 100 plus 2 by 100. Multiply this term by 2. So this could be 1 plus 2, 3 by 100. This is delta F by F. This is a relative error that has been associated with the measurement of mass. Okay. If I have been asked the percentage error, if I have been asked percentage error in the measurement of F, so I can write like this. It's a delta F by F multiplied by 100. Yes, it's a 3 by 100 multiplied by 100. While cancelling this, it is a 3 percentage. It is a 3 percentage. Yes, understand? Okay. Let's take a look at the new numerical. Let's say I have been given a mass which is 200 plus minus 2 kg. I have been given a volume of an object which is 100 plus minus 1 meter cube. And I have been asked the error or I in the measurement of density. So this is all that they have given. They have given a mass, they have given a volume, and what they require is they require the error in the measurement of density. So first, do you know any relation that relate mass, volume, and density? Think, think for a while. Yes, you got it right. It's a density is equals to mass by volume. So what I can write a error relation would be delta d by d. That should be is equals to delta m by m plus delta v by v. So delta d by d is equals to delta m by m plus delta v by v. So while I write this delta d by d, I can find out delta m by m. What is delta m by m? It's an error associated with the mass. It is a 2. What is m? A true value associated with mass. It's a 200. Plus delta v, error associated with the volume. What is it? It's a 1. V, it's an 100. So this is 1 by 100 plus 1 by 100. This is equals to 2 by 100. But look at this. This is not an error in the measurement of density. This is a relative error in the measurement of density. What I need to find out, I need to find out the delta D. So delta D that should be is equals to 2 by 100 multiplied by D. Right? Okay. So now how could I find out the D? Now let's look at this. I know density is equals to mass by volume. I am here interested in the true value of a density. So I need to take a ratio of the true value of mass to the true value of volume. So true value of mass, it's 200 in our case. True value of a volume, it's 100 in our case. So this is 2. So what I need to do is 2 by 100 multiplied by 2. This is 4 by 100. Or rather I can say it's in 0.04. It's an error in the measurement of density. This is error in the measurement of density. Yes, clear? Any problem regarding this? Anything? No? Are you clear with this? Okay. Let's look at the next numericals. Now, let's say we have been given that we have been given that force that is acting on an object is 50 plus minus 2 Newton, and area of that surface area of that surface is 100 plus minus 1 meter square. I have been asked relative error. I have been asked the relative error and percentage error in the measurement of pressure. Now, you have been given a force has been given and area of cross section is given. You have been asked the relative error and percentage error in the measurement of pressure. Now, do you know any relation that relate pressure, force, and area? Any? Do you remember any? Yes, it's pressure is equals to force by area. Now, how could I find out the relative error? I should write it's a delta P by P should be is equals to delta F by F plus delta A by A. Yes, delta P by P that should be is equals to delta F by F plus delta A by A. Now, what is delta F by F? Delta F, it is the error associated with the force. And what is F? What is F? It's the true value of a force. What is delta A? It is an error associated with the area. What is A? It's a true value of A. So let's put up the value. Now, what is delta F? It's a 2. Here it has been given. What is F? It's a 50. Delta A, it's a 1. A, it's a 100. So I can write like this. It's a 2 by 50. So it would be at 4 by 100 plus 1 by 100. Which gives me a 5 by 100. This is a value of delta F by F. Delta P by P. Sorry. So I can write like this. This is the relative error. This is the relative error in the calculation of a pressure. Next, percentage error. It's a relative error multiplied by 100. So delta P by P multiplied by 100. This is equals to 5 by 100 into 100, which comes to 5%. Got it? So, does all things are clear? Yes. Can we move to the next? Okay, let's look at this. Next is the errors due to power, or we can say these are the errors due to exponent. Let's say I have been measured A, and which gives me a data of A plus minus delta A, while delta A is the error associated with the A, and A is the true value that has been associated with. And let's say I have been asked that if z is equals to a to the power n, then I can write like this, that delta z by z is equals to n times of delta a by. So I can write like that, whatever the power would be, whatever the power would be, that power would be multiplied with that number. So delta z by z is equals to n into delta a by. So let's look at in more general way. Suppose we have been given that z is equals to a to the power n, b to the power b to the power q, and c to the power r, and I need to find out maximum fractional error. And what I can write like is it's a delta z by z. Now power of a, it is a p, so this is p multiplied by delta a by a. Power of b, it is a q, so this is q into delta b by b, and power of c, it's an r into delta c by c. Here let's look at this again and again, because even though c to the power r is divided, it would be added only. To remember my what? Errors are always added. Errors are always added. They cannot be subtracted. Errors would be always added. Do remember this thing. So, can you do it? Okay. So this is delta and delta z by z. And if I have been asked the percentage error in it, so I know that it is a relative error multiplied by 100. When I need to find out the percentage error that is associated with it. So what I can know is it is a maximum relative error multiplied by 100. So it will give me the answer, maximum percentage error. Yes, can you do this? Let's look at the questions. Let's say suppose I have been asked that z is equals to a square b divided by d to the power 4, and I need to calculate, find fractional and percentage error in z. So let's first work for the fractional error. How can I do it? This is delta z by z. What I need to do is I need to just multiply the number with the power. So it is 2 multiplied by fractional error of it. It is a delta a by plus b is having a power 3. B is having a power 3. So it would be a 3 multiplied by fractional error of b. It's a delta b by b. Next, d is having a power 4. D is having a power 4. So this is plus. Do remember, errors are always added. We cannot subtract it. So this is 4 multiplied by delta d by d. Yes, this is the fractional error associated with the z. Now let's move to the percentage error. What I need to do is I need to just multiply this. I need to just multiply this with 100. So this is 2 into delta a by a plus 3 into delta b by b plus 4 into delta d by d. This whole bracket would be multiplied by 100 and the things will be done. Yes, are you clear with this? Are you clear? Yes, absolutely. 100%. Okay, let's move to the next question. Now, z is given as a to the power 4 b square divided by c to the power 3 and d to the power 4. Now, I have been given that errors in measurement of A, B, C, D is 4 percentage, 3 percentage, 2 percentage, and 1 percentage respectively. Find percentage error associated with Z. Now let's look at this question very carefully. What they have given is they have given a certain relation, such like Z is equals to A to the power 4 multiplied by B square divided by C cube into D to the power 4. They have given the errors in the measurement of ABCD as in 4 percentage, 3 percentage, 2 percentage, and 1 percentage respectively. And you need to find out the percentage error associated with the Z. So they have already given the data in percentage. What you need to do is whatever the answer you are going to receive, whatever the answer you are going to receive, that would be automatically come into percentage. So it is by default delta z by z into 100. Now what you need to do is you need to just multiply its fractional error with its power. So this is 4 into delta a by a plus, do it your own. What should I write? Yes, correct. It's a 2 delta b by b plus plus it's a c cube. So I should write 3 into delta c by c plus 4 into delta d by d. Now let's apply a value in this delta a by a. It's in 4 percentage plus 2 into 3 percentage plus 3 into 2 percentage plus 4 into 1 percentage. So this is 4 fours are 16 plus 6 plus 6 plus 4%. So this comes to in 16 plus 6, 22, 22 plus 6, 28, 28 plus 4. This is 32 percentage. Yes, let's look to the new question. Very important. Let's say I have been given a simple pendulum, and time period of simple pendulum can be calculated as 2 pi under root of L by G, where L is the length of a pendulum and G is the acceleration due to gravity. G is the acceleration due to gravity. If I have been given error in the measurement, I have been given error in the measurement of time, basically it's a time period, is let's say 4%, and in the measurement of length, it's a 2%. Now I need to find out. I need to find out error in measurement of G. So basically, I need to find out delta G by G multiplied by 100 percentage. Go through this very quickly, but very precisely. Let's look at this. Can you do it? Can you do it? Think for a while. Think. This is all that has been given. They have given the relation. It's a 2 pi under root L by G. They have given the error introduced in the time period. They have given the length, error in the length, and you need to find out the error in the measurement of G. So what should I do? Let's look. They have given T is equals to 2 pi under root L by G. Percentage error in T itself 4 percentage. Percentage error in L 2 percentage. So on a first, what I need to do is I need to write T square should be is equals to 4 pi square into L by G. I just square it. Now I need to apply error due to power. It's twice of delta T by T. Now look at this. This is a constant number. 4 into pi square is a constant number. And any number cannot have any error. You just drop it. You are having an L that I should write as a delta L by L. And you are having a G. You should write as a delta G by G. Now what you required is you required a delta G by G. So delta G by G should be is equals to twice of delta T by T minus delta L by L. If you are doing this, you are making a big mistake. You should write as in plus. Why? Remember the words. Errors are always added. So do not make a mistake of subtracting the error. So what you should write is delta g by g, it should be is equals to twice of delta t by t plus delta l by l. Now, now what I should write is delta t by t, it is a 4 percentage. So 2 into 4 plus delta L by L. This is 2 percentage. So this comes to 2 into 4. It's an 8 percentage plus 2 percentage. That that will give me a 10 percentage. Yes. Are you clear with this? Any doubts? Any doubts with regarding this? No? Is it okay? Absolutely fine. Okay. Let's move to the new numerical. Next. Let's say I have been given a very good numerical. I have been given that if area of a square garden is 100 plus minus 1 meter square. I have been find out length of garden. So I have been given something like that. This is the square garden and its length could be L by L, and I have been given the area of that garden. I need to find out the length of a garden. Now, can you understand what I should find out as a length of a garden? What I required is L plus minus delta L. That means I am interested in true value of a length and I am interested in the error associated with the length. So what is given? That is the area. They have been given it's an area 100 plus minus 1 meter square. This is all what they have given. Now what can I do with this? What can I do with this? Think. Do you know any relation with the area and length? We have been given square garden. So I can write like this. Area is equals to L square. Yes, as area is given that is 100 is equals to L square. If I take a square root on both the sides, I can write L is equals to 10 meter. Yes, so well done. You have done half of the task. You know the now the L. Now your target should be a delta L. How could I do this? How could I do this? Right again, area is equals to L square. Now at this time, write down its error due to powers. What it would be? It would be an delta A by A. That should be is equals to twice of delta L by L. Now what is delta A? This is 1. What is area? It's 100. That should be is equals to 2 multiplied by delta L that is required and L that you have calculated. This is 10. So this is 10 tens are 100. So what I can write is delta L is equals to 1 by 20 meter. Yes. So well done. You did your job. Now length of a garden, which I should represent as an L plus delta, can be given as 10 plus minus 1 by 20th of meter. This is the length of a garden. While 10 is the true value, 10 is the true value, and 1 by 20 is the error associated with it. Yes, will you able to solve certain more questions? Yes, you find this interesting? Very interesting. Let's look at the new question. Next. Do you know kinetic energy? What would be its relation? Yes, kinetic energy is equals to half mv square. Any other relation? Any other relation? Anything else? other than the kinetic energy is equals to half mv square. Let's look at this. I know kinetic energy is equals to half mv square. Let's multiply and divide this with m. So this is m square v square divided by 2m. What is m into v? What is m into v? Think. It's a momentum, yes. So this is m square v square. This is p square by 2m. Yes. So you should remember that kinetic energy can be written as an p square by 2m. Kinetic energy can be written as an p square by 2m. Now, if, listen the question, if error in the measurement of momentum is 3 percentage, find error in the measurement of kinetic energy. While I have been given that mass remains the same, I have been given that mass remains the same. So what I should write is, I have been given mass remains the same. Only the things that would be changed is the kinetic energy and the momentum. So I can write like this: delta Ke by Ke, that is equals to 2 into delta P by P. I should repeat. This is a mass which is a constant as given by the data. So I should not write anything regarding the error for the mass. What are the terms that have been changed? It is the momentum only. So I should write delta K by K. It is equals to twice of delta P by P. So this is equals to 2 into 3 percentage. So I would get answer as in 6 percentage. This is the percentage error associated with the kinetic energy if there is an error associated with the momentum. Now here I want to put a very critical remark that when and when you are using the error, then the relation of errors can be used when error is less than 5 percentage. Here I should write error or change. If it is beyond 5 percentage, if it is beyond 5 percentage, that means I should not use it. Relations of error can be used when error or change is less than 5 percentage. If it is beyond 5 percentage, I should not use its relation. So let's look at the same question. Let's look at the same question. If momentum changes by 4 percentage, find change in kinetic energy. Well, that has been given that mass remains this constant. So what should I do is, I know the kinetic energy is equals to p square by 2, and that has been given that mass remains the constant. Here it is changing. They have not given that this is the error associated with it. This is the relation with the changes. We can use the relation of an error unless and until change is less than 5 percentage. So if change is within the limit, if change is within the limit, that means I mean to say if change is less than 5 percentage, I can use the relation of an error. So I can write like this: delta ke by k, that would be twice of delta p by p. Now what is delta p by p? What is delta pe by p? It is a 2 into 4 percentage. So it is changing by 8 percentage. This is the change in the kinetic energy. This is the change in the kinetic energy. Can you get it? Yes. Will you able to solve one more question? Let's look. If they have been given that if momentum of an object changes by 10 percentage and by mean of changing, this is it is increased by 10 percentage, then find out change in kinetic energy, find out change in kinetic energy while they have been given that mass remains constant. So think what you will do with this question. Yes, first you know the relation kinetic energy is equals to p square by 2m. Okay, go ahead. Next, delta k by k, this is equals to twice of delta p by p. Yes, then it would be a 2 into delta p by p, that is given as 10%, and then this comes to an 20%. This is change in kinetic energy. Yes, how many of you get this answer? How many of you? Yes, most of this. This is absolutely incorrect, and you should not use this. You should not use this relation. Now rethink and go through the data one more time. What they have been given that it object changes by 10 percentage. We can use relation of error up to 5 percentage only. Yes, so this is absolutely incorrect. Yes, do not make a mistake. So now let's look at the correct numerical. They have changed. They have been asked that delta P by P that has been changed by 10 percentage. It is exactly increases, and I need to find out the delta K by K. So now this time I need to take a ratio. What I have been observed is kinetic energy that is equals to P square by 2L. So what I can write like kinetic energy 2, it's a new kinetic energy, is equals to new momentum divided by mass. I cannot write new mass because mass means the same. Kinetic energy 1. 1, it is the notation for the previous one. And 2, that notation would be used as a new one. This is equals to P1 square divided by 2. Now let's take a ratio of this kinetic energy 2 divided by kinetic energy 1. This is equals to P2 square divided by P1 square. Now I have taken 1 as the previous and 2 as the new symbols. Now, when there is a data in the percentage, I can take 100 as a base. I can take 100 as a base. So previously it was 100 and newly that I need to find out. So I can write like this: new kinetic energy, I don't know. Previous kinetic energy, it is 100. Previous momentum, it is 100 into 100. And new momentum, as they have said that momentum has been changed by 10 percentage or it has been increased. So if base is 100, 10 percentage increment in the base, it would be 110. So this is 110 into 110. I repeat, as P1 is 100, and I need to increase this P2 by 10 percentage. So this should be 100 plus 10, which will give me an 110. So that's why I've written P2 as in 110 into 110. So let's solve this. This is gone. 0, 0 that has been cut it. It's in 121. But mind well, this is the new kinetic energy. You have been asked change in the kinetic energy. So initially kinetic energy was the 100. So this change in kinetic energy is 21 percentage. Change in kinetic energy is 21 percentage. Yes. So when and when they have been given a quantity that has been changed by more than 5 percentage, you need to use this methodology. If changes is less than 5 percentage, if changes is less than 5 percentage, you can go with the errors. Yes. Can you do one more question? Okay. One more thing. Here the momentum has been increased by 10 percentage. So this change is 21 percentage. But will it be increase or decrease? How could I get it? As I know this momentum and kinetic energy, I can write like this. They are directly proportional to each other. So if momentum increases, kinetic energy must be increased. So change in kinetic energy is 21 percentage and it increases. So it has been increased by 21 percentage. Would it be clear? Any difficulties? No? Okay, let's move to the next numerical. Suppose I have been given, suppose I have been given that z is equals to x square divided by y to the power 4. If x changes by 3 percentage, here it is increases, and y decreases by 2 percentage. Find change in z. Look at the data very carefully. And one more time, please be quick. Yes, they have given z is equals to x to the power 2 and divide by y to the power 4. If x increases by 3 percentage and y decreases by 2 percentage, you need to find out the change in z. So here all the errors associated with x and y is less than 5 percentage. So I can use the data as an error. So delta z by z I can write like is this is 2 into delta x by x plus 4 into delta y by y. Now remember the one thing. Here z and x square, here z and x square both are directly proportional to each other if we forgot the y to the power 4. So if x increases, z should increase. So I should write as in positive. Now here y decreases. So if y decreases, z increases. So I have written as in plus. if if let's say if y increases, if y was there which is increases, I need to write this as a minus. So please mind well, you need to apply a simple mathematics because these are the questions of the changes, not the errors. And while we are using the questions of the errors, while we are using the question of the errors, or we are using the relation of the errors, we need to apply a simple mathematics when question is of change. So here it is a twice of delta x by x plus 4 times of delta y by y. So this is 2 into 3 percentage plus 4 into 2 percentage. So this is equals to 6 percentage plus 8 percentage, and this is equals to 14 percentage. It will increases by 14 percentage. This is delta z. Yes. Are you clear with this? Yes. So let's look at certain MCQs. Yes. What is given? They have given if y is equals to a by b, then maximum percentage error. Now, what is the percentage error in this? Delta y by y. That I know it's a delta a by a plus delta b by b. I have been asked maximum percentage. So I need to multiply this by 100. It's a delta a by a into 100 plus delta b by b into 100. This is error. It should look like this. Yes. Next question. Instrumental error can be minimized by, you remember? Yes. So let's look at the options. Taking large number of readings, using different accurate instruments for the same reading, adjusting zero of the instrument, and maintaining the temperature of the surrounding. So how I can minimize this? How I can minimize this? Did you remember the random errors? Yes, absolutely same. You need to take larger amount of readings. So that can reduce the error or that can minimize the errors. Let's look at the next question. The magnitude of the difference between mean value and each individual. Remember this absolute error that is equals to a bar minus of a1 and so on. So this is an absolute error. Yes, comfortable with this? Okay. So let's shut it down. We know now what is error, how that can be calculated, what are the different categories of errors, what are the combination of errors. We know now the multiplication, addition, summation, difference, and power, and we must know how to use it. I request you to do a practice of this kind of questions from your given data and practice at least 80 to 100 questions of the errors. That will make you nearer to the perfect one. Yes? Okay. Let's sign out. Thank you. Goodbye. Take care. Bye bye.